This video is on calculating percent composition. We'll start with this formula that tells you if you want to find the percent by mass of each element in a compound, you have to first take the mass of the element in 1 mole of that compound and divide that by the molar mass of the total compound. So let's take this example of NaHCO3, baking soda. If we want to determine the percent composition of them, we begin with our mole ratio that's taken from the formula. 1 Na, 1 H, 1 C, 3 O's. And we want to change that moles into grams because we have mass. We want mass, which is always in grams. So therefore, for sodium, we're going to use the molar mass of that, 22.99 grams in 1 mole. And I multiply these guys together, and I get 22.99 grams of sodium. For hydrogen, I'm going to use 1.008 grams in 1 mole. That's the molar mass. So that gives me 1.008 grams of hydrogen. For carbon, I'm going to use 12.01 grams in 1 mole. And again, notice that moles are here and moles are there, so they cancel out, which that gives me 12.01 grams of carbon. And last but not least, I have oxygen, where I have 16.00 rounded. This lovely textbook likes to round, in 1 mole. And so that will give me 48.0 grams of oxygen, because again, 3 times 16, I got to multiply those guys together. So that gives me the first part of my equation, the mass, the amount of grams in 1 mole of that compound, of each element. So now I need to find the molar mass of the entire compound, which is where I simply just add these guys together to get the molar mass of NaHO3. So we add those all together and we get 84.01 grams per mole, because that's what we've got, grams per mole. So far, nothing new. Haven't done any different work mathematically than what we've done already previously. But here comes where I use the formula. I now have the mass of each element. I now have the molar mass of the compound. So let's simply divide these two together. And then we need to multiply it by 100. I forgot to add that piece there because, of course, this is a percent. So we have to multiply our answer by 100. So back to our piece here. We'll take this guy and divide it by 84.01. We'll divide this by 84.01. 84.01 and 84.01. We do our math, and we get 27.37% of sodium, because of course it's that number multiplied by 100. Here we get 1.20% of H. Again, these two numbers multiplied by 100. For carbon, I get 14.30% of carbon. And last but not least, for oxygen, I get 57.14% of oxygen. We add all of these percents up, and it should equal to 100%. So that tells me that baking soda is almost 60% of its mass comes from its oxygen, and almost 30% of its mass comes from sodium. If you haven't want to try this on your own, here's a practice problem you could do. We have caffeine here, C8H10N4O2. If we determine the percent composition, go ahead and pause the video, see if you can figure that out, and then come right back and check it out. I'm assuming you paused and you're back, and here are your answers. Almost 50% of caffeine comes from carbon, 30% from nitrogen, 5% from hydrogen, and 17% from oxygen. If you need more clarification, chapter 10.4 in your textbook is where this is covered.